Good afternoon, everybody. I think we are online. Good morning for people listening to us from North and South America. Good evening, maybe if we have some people listening to us from Asia. So Arne and me will start the webinar about the FREEcure technology from IST MES. We wanted to make this technical webinar to give you as much information as possible about this technology. Arne will go deeply into a lot of details about this. Arne, when you think you are ready, you can start. We have 45 people connected, but I think more people will join soon.
Thank you very much, Romain. So welcome to today's webinar on FREEcure. It's where ideas meet impact. We are honored to have partners, supporters, and curious minds, and even some of our competitors joining us. That's a proof that true progress thrives on diversity, collaboration, and the courage to challenge the status quo. After all, when it comes to advancing FREEcure, we are all striving towards the same goal: better solutions, stronger ideas, and a healthier future for everyone. So I want to introduce ourselves. Romain, maybe you can give some information about you.
Yes, of course. I'm the co-managing director with Jonas Pesanti of IST France, and since 2025 also of UV IST Iberica.
And myself, I'm head of sales for web and converting applications. I'm since 22 years with IST MES, and in my actual role, I'm responsible for the FREEcure technology in web and converting applications. So some words about the way we pass through the presentation. Romain, can you give some information?
Yes, of course. So as you can see, the webinar is hosted on Teams meeting. On the top of your window, you can have some logo. If you're in the English version, you will have a logo called chat, and the other one will be question and answer. You can use the logo and the question and answer logo to ask us many questions. I will make a test during the presentation of Arne. And at the end of the presentation with Arne, we will go through all of the questions and try to give you as much as information and to answer as good as possible. And to make this webinar a little bit more live, we will propose you some polls, so some questions during the presentation, and the window will pop up on your screen. You will just have to select one or several questions depending on what you believe is right or not. If you don't know, don't hesitate to say I don't know. You can select it, so it will help us to understand if what we are telling you is useful or not. So yeah, I think that's it for the technical part of the webinar.
So just an overview about the topics we will cover. We'll give an introduction, a brief overview of photoinitiators and their important role in curing. Not to misunderstand, we don't criticize initiators. They are very important. They enabled UV technology. The only question we put on the table is if the amount we find them in today's formulations is really necessary when using a second curing mechanism. So we focus in this presentation on free radical photoinitiators. We won't cover cationic ones, as their importance is pretty low when we have a look on the volume of the chemistry used in processes. So we explain the mechanism and the main challenges, the danger, because some initiators pose health risk, and there has been numerous initiators in the past that have been put on REACH list or that have been banned. The cost, specialized photoinitiators can be expensive. The role in regards to food contact, we have a limited use in food packaging applications. Yellowing causes discoloration, in fact, the appearance, and not at last the the production of greenhouse gases due to the complicated production of initiators. Then we cover oxygen. Oxygen reduces curing efficiency by inhibiting the polymerization. And we will have a look on the possibilities we have with FREEcure to get rid of oxygen inhibition and to avoid tacky surfaces due to radical trapping. So then in the last part, we have a look on FREEcure if it can be a solution. The way we create double bondings without use of photoinitiators using higher electromagnetic energy. We have a look on a comparison between a FREEcure lamp and a conventional mercury lamp. A look on the spectrum, where is the strong point, where is the strong energy output in a FREEcure technology. The applications, I will give you some information about applications we covered where we supplied the FREEcure technology. And yeah, let's start with the topic of the photoinitiators. And here comes our first question. What do you think what percentage of the total mass in a UV formulation do photoinitiators represent in average? Roman, you can put.
So normally everybody, you have a windows that pop up in front of you. You can select the answer you believe is right. And we will let you, all of you, some seconds to answer it. For the moment, we have almost 35 answers, 40 answers with 70% of people telling 2 to 8%, 30% of people thinking that we have 8 to 15% of photoinitiators.
Well, okay. So the right answer is 2 to 8% in average. There are always exemptions, but in average it's 2 to 8%. Besides oligomers, reactive monomers, additives, pigments, or additives and sensitizers. So in average, we find 2 to 8% in commercial formulations. When it comes to the registration we have in Europe, and there's a counterpart in the US, we have the REACH, the registration, evaluation, authorization, and restriction of chemicals. This is a regulatory framework to ensure that chemicals produced and used in the EU do not harm human health or the environment. In US, it's covered by the Toxic Substances Control Act, and which has the task to regulate the manufacture, import, use, and disposal of chemical substances in the US. And we have a long list of substances that have been classified and banned. And this initially has been for us a motivation to think about the future, because at that speed of classification, it's foreseeable that initiators get less and less, and that the choice for the formulators get less and less. And that has been the reason for us to find technology that enables direct cross-linking only with the use of energy. We have, besides the REACH TSCA, the need to label and classify the hazard toxicity with the CMR, the carcinogenic, mutagenic, or reprotoxic toxicity of substances, and to put a label on the container. And basically, these hazard labels are due mainly to photoinitiators. The CLP regulations ensure that the hazards of chemicals are clearly communicated to workers, and we find here three classes. We have worldwide the GHS system, the United Nations globally harmonized system, which will put together the requirements, the national requirements, more clear in the future. So just as a question, which was the last photoinitiator to be reclassified as CMR? This is a tricky question because there have been recent developments that reclassified the reclassification.
Yes, it's always moving. So you guys can answer the polls. We have, for the moment, 44% for the TPO, 5% for the TPOL, 26% for the 184, and 25% I don't know.
So the right answer is indeed the TPO, because 184 has been reclassified, but with a date of 31 of October, the reclassification has been reclassified so that there is actually a little bit of insecurity in the market. It's not very clear what ECHA is doing here, but it's just to picture that we have constant activities to examine initiators, and there's a constant risk that they will be reclassified, banned, or put out of service. When it comes to the cost, we have roughly, it's always a rough average we are giving here. The photoinitiator cost in a formulation can reach 20%, it has 20% of the economic weight, and so it's an important factor to have a look on it. When we come to IDFC, there is no application with direct food contact. The initiators largely drive the regulatory status and hazard classification. We have in Germany the German Ink Ordinance coming into to be put into the industry from beginning of 2026. We have had the Swiss ordinance. We have several regulatory frameworks that specify migration levels. So it's always an important point to have a look on, and tendentially with low or no photoinitiator content, we have tendentially lower migration as well. It's similar.
Arne, I have one question for the indirect food contact. If we reduce the amount of photoinitiators, so we will, of course, reduce the photoinitiators migration, but because of the high power of the FREEcure, can we create migration of new elements that have been activated because of the strong energy?
We have had lab analysis a couple of weeks ago, and there has been no additional substance compared to a normal initiated formulation. So up to now, I mean, it depends always on the formulation, but up to now, we have no information about that. It seems that we just eliminate the initiators and reduce the migration levels for this class of substances. We have no findings that there are acrylates or reactive molecules that can be found in the migration test.
Okay.
The same applies for yellowing. If we reduce the initiator content, we will reduce as well the yellowing effect. And after all, the initiators have a strong impact on greenhouse gases. That is simply due to the fact, because their manufacture involves multiple reaction steps, often they come along with pretty low yields, and as each step requires solvents, reagents, catalysts, and purification, they all consume energy and generate waste. So the production of initiators influences the entire ecological balance of the formulation in a negative way. Some words to oxygen. Oxygen is generally the effects when we have inhibition at the surface. We all feel the tackiness. The ink film or the varnish film is cured, but at the top we still feel the tackiness because oxygen is a disruptor of chemical reactions. And we can overcome this by inertization with nitrogen. But with a look on the table on the right side, the nitrogen costs have risen. They have doubled up to 2023 due to the simple fact they are proportional to energy costs. You need energy to produce the nitrogen. And they came down a little bit, but they are still a very important cost factor in production. And the same effect, the avoidance of inhibition, can be done by using strong UVC sources. On top, if you use direct radiation, you don't have the quartz screen between the lamp and the substrate, which gives you more effectiveness. And yeah, we want to analyze these points. How does FREEcure behave in terms of these challenges? We find here first the technical way we create these double bondings. It's just a derivative from the Einstein-Planck formula. Carbon double bond has a energy of 500 to 600 kilojoule per mole. You have to overcome that, and for that you need approximately 6.15 electron volt. 1 electron volt is 1240 nanometer. It's a definition. You divide by 6, you find yourself around 200, 220 nanometer. So that's the wavelengths you need to create direct double bondings. I share here the source BASF. We did all these analyses together with the RedTech group of BASF. They put the polymer know-how inside. I just wanted to thank and to make the remark that this was common work. So with this wavelengths, we are able to create double bondings. We now have to have a look, how did we do that in terms of building a suitable lamp. It's the wavelengths we see here on the yellow side in the case that is necessary at a very strong intensity. And how could we transfer that into current technology? So the thing is, we had to optimize the plasma within the UV lamp. We had to optimize the coating of the reflectors to be able to reflect these ultra short wavelengths. And last not least, the electronic control to drive the lamp is a complete different one from what we find in a conventional lamp. When you see the lamp from outside, the footprint is exactly the same than a standard IST lamp. The lamp is differing, but the housing, the size of the housing are completely the same. We install it in our proven BLK technology. And so it is possible as well to retrofit or to change existing positions to FREEcure technology. In terms of output, here you can estimate.
Yeah.
So what is the UVC gain of FREEcure compared to a conventional lamp? We compare only our technology, where we have still in the standard solutions a pretty high output in UVC. So do we have some answers?
So, yeah, we have some answer coming. We have, yeah, it's shared between 32% and 74% for the moment, and roughly 20% of people doesn't know.
So let's go to answer this question. In average, so the curve, the amount under the integral is plus 74% over all wavelengths, but, and here it comes, we have certain wavelengths where we have a factor of 9 to 30 stronger output in singular wavelengths, enabling us to get the effect, the desired effect of direct cross-linking without initiators. It's a very high amount of radiation at 210, 212 and below. And here we find the energy. The electromagnetic energy is as higher as we go down in the spectrum. And here we find the values around 6 electron volts that we need to crack the bonds.
And so, Han, does it mean that if we use a FREEcure technology, we will have ozone like with a classic mercury technology?
Yes, of course. I mean, ozone is created in these lower wavelengths and is similar to existing UV technology, but as a lamp operates in under pressure, there is no risk and no smell or whatever for the operating personnel around. Everything is aspired in the exhaust, and as ozone is an unstable molecule, it falls apart after 3-4 meters in the exhaust.
Yeah, okay.
So some words on application. We start with a very traditional one. It's the curing of aqueous varnishes for the wood industry. We did trials with a lamp with 200 watt. The operating speed has been 30 meter. And we see two formulas which have been cured with a standard AG medium pressure lamp. And then afterwards with a UVC lamp and an adapted formulation. So we see on the left side the double bond conversion with photoinitiator, traditional way to produce coatings in the wood deco application. We have conversion rates of 65 and 55%. When taking out the initiator with a normal lamp, we reach 6.5 and 34, which is way too low. And in taking out every initiator and curing with a FREEcure lamp, we top the conversion degree that we initially had with photoinitiators. So these have been the first results that we had in the past and that are very promising, because with the reaction without initiator, what comes in parallel is that there is no smell of the formulation, the cured formulation. Total absence of smell, which is an important and interesting feature for the furniture industry. When we have a look on the mechanical resistance, we can compare again the mercury lamp with PI, the mercury without PI, and the FREEcure, and we see that we reach similar mechanical values, tendentially around what you get with mercury, so that we can state that the mechanical resistance is similar. and as well as a caustic resistance, which we had a look on later. A look on the printing industry, we had a couple of installations and results here. For flexo inks with ultra low migration then defined with no initiator in the varnish, and a little bit, because you need it when you have a pigmented solution, you need some through curing at some point. We cannot penetrate with the UVC the entire layer. We reach with one lamp, all the values are recorded with one lamp, we reach 150 to 200 meters, which represents a satisfying production speed. And the observations curing was really okay. We even had a case where in the tape test, the printer went away to fetch a second tape because he thought his initial tape was too old because there was no fraction of ink sticking to the tape. The adhesion is excellent due to the very high cross-linking degree in the polymers. It's a very dense cross-linking network. I come back to that later. Then we had coatings where we reduced the existing initiator in the existing formulation to 1/5 and reached the production speed of 160 meters per minute, which was enough for the application. The only difference is that there's been only 1/5 of the initiator in it, and the coating cured as normal. So then we had that application together with our friends from Comexi that they showed on the Label Expo in Barcelona in their plant. It's the first down white in the wet flex system. They print a white as the first color to overprint it then, and we reached with one single lamp a speed of 200 to 250 meters, and end of press it was cured with EB. So here in that case, FREEcure enabled the curing of a modified electron beam ink to overprint it wet on dry. And then we have a couple of formulators now proposing offset inks, entirely PI free. Here again, the average speed we reach is between 150 and 200 meters per minute with very, very good curing results. Screen printing, it's clear we find here thicker ink layers, so that we saw results with one FREEcure at 25 meters per minute, but still completely photoinitiator free. And a technology that has been surprising for us that in the beginning we did not target with the FREEcure is inkjet. Inkjet is very, very interesting, the findings we have so far, because I mean, inkjet is, the droplets are fully inhibited with oxygen when they fly through the air. So you can use an inert atmosphere to reduce that. But basically, we found that when we use inerted atmosphere and reduce the photoinitiator content, which is pretty high in inkjet formulations, to 50%, we were able to print almost every inkjet ink in the market with satisfactory results with only the half of the initiators. And that has been just the beginning. In reformulating and using additional mechanisms like an amine modification, our partners have been able to reduce the photoinitiator content down to 12% and even lower. And that is a pretty good achievement for inkjet technology. So in industrial applications, we had a couple of different experiences. First in coil coating, a clear top coat, completely PI-free, 10 microns thick, 20 meter per minute in inert atmosphere, full curing without any initiator. Then primers have been cured, same speed, full curing, inert and a little bit preheated with 1% PI, much less than usual. They run close to 100 meter in inert atmosphere with full curing. So it shows a little bit the spectrum you can achieve in reducing the initiator to a minimum to realize any desired production speed, because 100 meter in coil is already something. Silicones has been very interesting as well. Almost every formulation we got in our lab, we were able to cure it with one FREEcure up to 200 meter. That is usually the speed we cure with a full initiator content. And without any initiator, silicones could be cured up to 60 meter per minute. So that would mean to add additional lamps to get higher with the speed, or to add a fraction of initiator. We found that especially in silicones, we were able to reduce substantially the amount of used initiators. Then we had that example with the top coat for the furniture, spray up 200 micron, and one FREEcure was enough to cure it completely PI-free. And when you have in mind that in these lines, normally you find 6 to 8 dryers, we have projects where we were able to replace them by only one, and for security, 2 lamps. Primer on melanin foils, one FREEcure up to 15 to 20 meter, completely PI-free, and adhesion was really good. In metal packaging, the same. There are already products commercially available in the market. One FREEcure, 200 meters, completely PI-free, good curing. Very important for metal packaging to have a smell-free coating and ink. In PVC flooring, the same, aqueous base, and with the FREEcure, we had a 7 to 10% higher conversion rate than with the usual formulation. So these are very, very encouraging results. And the common properties, a tendency over all applications, we found that we find an excellent adhesion on a wide range of substrates due to the very dense polymeric network. We have a completely odor-free coating after curing. In all of the cases, we could increase the machine speed significantly, even with existing inks and varnishes, because in a lot of applications, the lack of UVC is the limiting factor. In almost every application we had in our lab, the amount of initiators could be reduced and substantially reduced. The varnish bendability on folding cartons is very, very good. That is a statement from our customers. Seems that this dense polymerization enables the flexibility and the crack resistance. And in other applications, we have a very good deep drawability. So here again, we find results that could be useful in that or that application. And in the varnish applications, we can reduce UV lamps required for the curing. And we have a lot of examples where we could reduce from 8 to or from 6 to 2 without compromises in the curing quality. But as always in our industry, it's difficult to generalize. If you are interested to see what FREEcure does in your application, you are cordially invited to go in contact with our UV Technology Center. The contact is Oliver Staatsmann, my colleague, and we can book a time slot for you. We can do common trials, and you can see on your own application how FREEcure gives you the desired better results prior to make an investment or so. This service from our side is cost-free. Please contact us, and all in all, we see very, very good results in installation in the market, and things as this can contribute to reduction of, not elimination, never, but reduction of initiators in formulation and better quality in curing in UV. So thank you very much for your attention, and I think we can hand over to Romain, who got some questions, I think.
Yeah, thank you, Arne. We can go to the... Thank you very much for all your interest. Arne, you can stop the sharing of the screen. We will... So we have already some questions. First one from Anthony. How does the energy consumption of the FREEcure lamp compare to a standard mercury lamp?
It's for the same formulation, it's the same, even tendentially a little bit lower. I would like to start with another question. What is the maximum coating thickness FREEcure can penetrate? Yes. Because for the simple reason, it will explain the other question as well. Are there less amount of UVB and UVA in comparison with the conventional arc lamp? No, there is exactly the same output of UVA, slightly higher in UVB, and strongly higher in UVC. So the spectrum is a continuous spectrum that you can use to cure your existing formulations, like the ones without photoinitiator. And in this case, you need slightly higher energy. That is why we built it with a output up to 240 watt per centimeter to enable to this direct cross-linking effect. So energy consumption is slightly higher, but then you get rid of all the initiators inside.
Also, if we, for example, if we have some application where we replace 4 to 6 lamps with only 1 or 2, we also reduce the consumption. Of course, one lamp consume as much, one FREEcure lamp consume as much as one mercury lamp, but as we have more efficiency, we can maybe have less lamp for the same process. So at equivalent process, we can sometimes, which is one advantage, reduce the complete electrical, the total electrical consumption of the process.
So the next question is, on which substrate CMYK Flexo inks were tested and has been successfully cured? Top-coated films. Does it work on corona pre-treated BOPP too? Yes, it works on BOPP. We had when we had our UV days in summer, we had a flexible film material that has been printed. We have samples for that. But I would, Harald-san, I would recommend to go in contact with Oliver Staatsmann and to do the tests on your actual material. That's the best way to get an answer to that question. But we have numerous film materials that we have been coated, and there has been no difference to existing formulations. It is for inks as well as for varnishes. Yeah. Okay.
One question from Eric Sievelberg. did you come across chain scission of defunctional oligomers, essentially making two monofunctional oligomers? If so, do we need to adjust our formulations to compensate?
I don't see the question.
You don't see it?
Have it in. I don't see that question here. Here
It's
again,
in
the best. Ah, now I have it. Eric, sorry. No, we have had no chain scission up to now, but I cannot answer this question if you need to adjust your formulation because I don't know it. Here again, the best is the test. Send us some of your formulation and we can cure it. And then you can make the analytics in your lab. Generally, what we do is we measure the cross-linking degree with FTIR. We have the possibility to use DSC, but we don't evaluate this headspace chromatography or else. We give that to external labs. So if that is a concern for you, you are welcome to send us some material. We can cure it and you can do the analytic on your own. I hope that it is a satisfactory answer to your question. Then, did you see difference about gloss level and the aspect of surface curing? Aspect of surface? No, there's no difference. There are some variations. Sometimes it depends. When you have a lot of surface active initiators in your ink, especially we saw that in some type of formulations, but when you reduce them, you have the same gloss level and the same surface aspect. So how do you monitor the curing level? That is by FTIR, and most of the time we reach curing levels above 95%, 97%. And our analytical device for that is the FTIR spectrometer. What is the expected lamp life compared to a standard arc lamp? It's similar. It is the same technology. Quartz has a higher transmission, but lamp life is expected to be similar as well a normal standard life has when it runs in a clear room, much higher life expectations than we see it in the industry. And do you, here again, the same question, do you see any reduction in gloss when curing with FREEcure? No, we did not see that. Okay, I think, is there still open question?
And we have another question for Sonny Liu. What is the lifetime of the FREEcure lamp and has similar power supplier as other mercury lamp? So about the lifetime, we speak about a lifetime equivalent to our standard mercury lamp, which is about 3,000 to 3,500 hours. It will depend mainly on the application. But yeah, the lifetime, as Arne said, is basically the same. Regarding the power supply, no, the power supply is slightly different because it's one of the innovation in the FREEcure technology, which allow us to improve the irradiation in the UVC spectrum. So the power supply is not exactly the same as for a classic mercury lamp. And I think I'm trying to refresh, but I don't see any other questions. No.
Well, so
Very good.
I hope that we could give you some useful information. Again, if you have additional questions, feel free to contact us, to visit us, to to do trials to get into the real application. We would be happy to assist you in finding out if FREEcure could be a suitable technology for your application. I want to thank you very much that you have been part of this webinar. We are really happy about the good response, and I wish you all, depending on where you are, a nice rest of the day or a
Good morning.
successful working day.
Yeah.
So
Thank you.
Thank you very much.